Okay, so welcome. Today we're going to be doing the USACO Silver Contest for February 2022. Hopefully this will help you get an idea of how someone would solve the problems, like how to prioritize the problems, and just kind of like what USACO contests look like um, when you're participating in them. So we will get started then. Okay, let's get started. Okay, so there's 3 problems. We'll want to try to read all of them before deciding which one we want to work on. Of course, if there's one that we find easier, we should do it quicker. So we'll take a second to read the problem. Okay, so we have n gifts and n cows. N is small, so maybe we think something that might be quadratic. And then each cow has a wish list. Okay. So in this case, these are the gifts in priority that each cow wants. And initially, this cow gets 1, this cow gets 2, this cow gets 3, and this cow gets 4. And I guess the sample, well, for 1, you can't get better than 1. 4, why can't 4 get better than 4? Like what happens if you give 4, 3? This one has to take 2 or 1. You can't take 1, take 2. This one takes 3, and you're stuck. And I guess the same applies with 2, and you can't take 1. Okay, so we can kind of see how the sample might work. I'm not entirely sure how to solve that right now. We know n is relatively small. We might want to take some time to write out and think about that one. But I think I understand what it's asking at least. Actually, robot instructions. Okay, so you want to select some set of these instructions to get to a point. N less than 40 is quite small. So in this case, if we wanted to naively try them all, it would take us like 2 to the k time. But there's actually a technique called like meet in the middle. And I think that's probably what we're going to do with this problem. So we can discuss that in a second, but this seems like a great one to start with just because I recognize the technique. And we'll discuss what it is and why 40 and something that you can like enumerate in 2 to the n time makes that clear that that might be a good technique. And then we have this one. This one's pretty long, it looks like. So some set of folders, some set of emails, and each email needs to end up in a folder. But we can only view k of each at once. Okay. So you can kind of like scroll, but you can't scroll up. Yeah, I get the impression this might be like a lot of implementation. I'm not sure exactly how to solve this one either. And so we'll want to come back and think about this. Just 1 second. Okay, so for this one, we'll come back to it. It seems like there's a lot of details to worry about, and then you have to like deal with once you reach the end, you can kind of scroll up by removing emails at the last k emails. And that's a lot of sample data to think about. yeah. So robot instruction seems like it will probably be the easiest. So we can start by thinking about this one. Okay. So in the case of robot instructions, we could try every k from 1 to n, I believe, and just all like n choose k choices, or we can also do the same thing and just enumerate all to the n choices to pick a subset of instructions. And so that's really slow, right? We have n less than or equal to 40, and 2 to the n will TLE. But 2 to the n works for about n equals 20. So 2 to the n, where n is less than or equal to 20-ish, maybe 22, 23, this will pass. So that's why we're going to start thinking about meet in the middle. Because what we can do is we can enumerate. There's this technique called, let me go back to the meet in the middle, where we'll split. So this is like n over 2 elements, and this is n over 2. And if n's not even, you split them, put one more in either one, and enumerate all 2 to the n over 2 over here, and do the same thing here. And so now when we're looping over the second, we can check whether left already has a valid link. Because we need to combine them such that we get to like, so I'll say pairing. We want to combine them such that we get something that sums to xg, yg. That's what the notation they used. And so we can have some sort of create a lookup table, create a table. In this case, since the values are large, we probably just need to do like an unordered map. And so we'll get something that's 2 to the n, but then we have to loop over k as well, in order to update, because we have to do this for each k, so we'll probably map for each k, and we need to, I probably have a for loop that's related to k. So it's probably going to be something like 2 to the n over 2 times n, because that's where the k is ranged from. So we're probably getting something like that. At least that's the expectation. So I think this should work, and we can try to implement this. Hopefully this shouldn't be too hard of a problem to do. This one seems to be the most obvious to me, so that's why I'm starting this one. And also the memory and time limits are larger. It's probably something to notice, especially because 2 to the 20 times 40 is a little large. So it's a good sign that we have twice the time limit, so it shouldn't be too big a deal. And if you wanted maximum points, this test case is just brute forcing it, and so it's probably the best way to do that. Okay, so we can get started with coding this one. We'll do it in C++. We'll start by just putting in a short template. I'll make this larger. The entire. Okay, hopefully that's large enough for for us to see. Oh, wrong. We can go to a shell as well. Okay, so in terms of the input, we have n pairs. So we'll take in the data we need. We can use pairs in C++. I'll make them longs just in case we want to do math on them. So these are the instructions. How many instructions are there? It's up to 40. Yeah, sorry. Okay, so we'll take in the input. That's our input. So we're going to want to construct lookup table on the left half. So let's first half, the size of half will be n divided by 2. If we want to, I'll seal it. So this will give us that. Now we want to loop over all possible subsets of the first half. And the way we can do this, is we can take binary integers like range from 0 to half. And now I want to do, let's do the sum of this part and we do need to keep track of the sum of this half. We also want to keep track of the number we used. We'll need to put that into our lookup table. And so now we can loop over the elements in this half. And the way we can check, because we're using integers as a way to loop over subsets of elements, and that's a very common technique, but we just use bitwise operations here. So we want to check if I and 1 to the j. So if we pick this element, then sum dot first plus equals j dot first and sum dot second. I need to add to the lookup table. So we're going to need to create this lookup table. In this case, we're probably going to want an unordered map, parallel, parallel, unordered map, parallel, comma, int. So in this case, this probably won't compile because I don't think it likes map of pairs. Pairs don't have a hash function in C++. I'm not sure if this will TLE. We might get really close to the time list. So in this case, lookup of sum use plus plus. So we've seen this and we'll just add it. Right half. Other half. And do the same thing. Now we have seen this right half. We computed what the sum and count are on this right half, and our desired sum. Oh, I forgot to take in the location. Is it the first or the? Okay, so it will be the last. First. Answer. So in this case, our parallel sum is going to be in loc dot first my sum dot second, and then the end. I guess this depends on which k we're processing. So we can either do this in a loop of k. Our answer needs to be an array. Two, one, because we can include n. Here we'll loop over k. In this case, ants of k plus equals lookup of needed sum, and then so in this case, this has to start at use, otherwise we'll end up with negatives and there's no reason to look up. I mean, it won't give us an error, but there's never going to be a case where those exist. And so now we can just print our answer. Input 0. Okay, so you can ignore the warnings. Those are because of my laptop. 0203010. And that does indeed match. This is actually an easy problem to test, like a largest test case, if we really wanted to, but USACO doesn't penalize submissions, and I don't think it's too important to test. Our bounds are correct. The only thing I would be worried about is there's a slight chance this probably TLEs when it. So we'll go and submit this. Not Java. 17. Let's see how it goes. Okay, so it's not too bad so far. It's a bit high. There's a chance, I guess it's 4 seconds is the time limit, so we're probably going to TLE on. Yeah. Probably the way we can decrease this. One, we're using a map, and I guess logarithmic factor would be nice to be using an unordered map. 2, we're using an unordered map when we could be using a vector. 3, we have that factor of n. It's not just 2 to the 20, it's 2 to the 20 times n. So I think this is the solution, but I think we need to spend a little time writing some better code here. So this is not actually too worrying. I don't know how many test cases there are. Well, probably going to TLE on all of them, I guess, sadly. Oh, no, we got the last one. So some things we can change. I don't remember how to do hash functions equals plus properly, so I'll wait on that. But this can be a vector of longs. No reason for it to be. If lookup dot or not lookup dot count sum. I'll switch to that. One. Plus. I guess another thing is auto. we don't want to keep looking these up. Reference and look up once. Okay, so those a couple small things, and just make sure it still works. Other warnings. Ooh, we gotta. Oh yeah, because if it's not, if test it. Okay, so it still works. We can go and submit that. Might take a little effort to get this to pass. There's still a pretty good chance that this TLEs, which is fine. Submissions aren't penalized. But this should pass a couple more. This runs very quickly on the test case with only n equals 20. Yeah, those used to be, that used to be like 2 seconds, I think. Yes. So we're definitely not gonna pass them all, but we'll get better. The last thing I would check is how to do a proper hash function in C++. Yeah, okay. We're allowed to look up language documentation, but I don't remember how to do this properly. It's like before. Okay. So we can take a hash function and use this. I feel like XOR is probably not a great hash function, but it's something I can start with. I think we just use it like this. See, still work? No. You know, it does work. I don't think XOR is great hash function. We'll see. We can do some testing. And then one other idea I have is to like not split it equally in half, but put more elements in the first half because that doesn't have the loop of k. So maybe it's in like 22 or 23 in the first half. Let's see. There's a chance this won't pass everything, but hopefully we'd see it pass a couple more. 3 milliseconds. Not much smaller than it was before. That is about a second smaller than it was before. Let's see if we get more test cases. Okay, so we're definitely still tealing some. So the other idea I have is this will be put 23. It doesn't matter if we don't split it in half when n is small. Like obviously when n is small, this just puts all in the left half. That's fine. I actually don't care there. Oh, we got way more. Okay. Actually, let me try 22. I don't want to split it too unevenly. So this will be the last. This should probably get them all. So the time it's clearly a bit tight for this one. Like you can get the idea and still fail. There were at least some easy optimizations to make. And I guess it's important to remember, like, even though things like unordered map per of 1, like vector is still like almost an order of magnitude faster. Unordered maps are like the logarithm factors do matter, even though like you got the idea, like it really should pass. You got to be careful with small. Well, that's not good. It's probably memory limit that's exceeding. But I guess because there's more. All right. Okay, let me lower that. I didn't think that would happen. Maybe it's because we're using vectors, technically using more memory than we should. We'll see how this works. I got everything but one. The last submission. So. Yeah, the more distinct sums there are, the much more varied, or much higher your memory usage will get. Okay, we have to be a little careful here. What should we do here? Oh, I guess what we can do is just do it all in one lookup. Really like that, but we'll see. Now we can't do that reference. Might get slower, a little. No, at least we can get the memory usage better. We'll do something like that. And it doesn't like hash. It doesn't. Still won't compile. Probably does not like the hash function, but why? Oh, you have to call the constructor. This part of the code is not even relevant. Problem, we just need to make sure. C++ won't support hashing pairs. All right. I'm not massively more confident this will pass more. I want to see what changes will get us the most. We do have the one solution that got us everything but one, which is pretty good, and you'll get promoted if you can like you miss one test case. So it's not a big deal to just settle with that. Time limits are much worse here. But the memory is way lower. So we traded off our memory for time limit, which is not what I want. Okay. Pretty sure we can get this to pass with a few more changes. Right, so we just want to lower our memory usage, but I think vector L was a lot better because the reason that's probably saving a good amount of time, because here, like this lookup, we do like quite a few times, and it's a lot more hashes to be doing that you don't need to be doing. So that's probably where we're losing most of the runtime when we resubmitted, even though it use slightly smaller. Okay. Maybe we can distribute. We tried 20, right? And that was what got us everything in one test case. And that was, I think that's where we were. Let's try this one more time. The issue here is this map gets pretty big, and when I tried to redistribute it to get more runtime, we traded off more memory, which is a trade-off. Because I originally tried like 22 or something, and I exceeded the memory. This will probably pass a lot again, because I think this was really close to what got us most of the test cases. But it's still probably going to fail one or two. It's really frustrating how tight the timelines are for this problem. So yeah, the memory usage is very high, but this is, I believe, where we weren't getting memory limit exceeded. We only got memory limit exceeded when we went for test case 8. Yeah, the memory limits are very, very high. And if you add a factor of 2 to the memory usage, yeah, we really can't. Another thing we can do is just change the value for our hash function. I guess this is probably gonna pass the remaining 2. Like, okay. It's possible we're just getting a bit unlucky with our hash function, or this is a badly designed hash function. So another thing we can do is just like a different value there. And there's a good chance it will change the runtime, because it can be unlucky with hash functions and they're deterministic. And sometimes it's useful if you're going to code your own hash function, make it randomized. Let's see if, I mean, that's the best guess I have to get the one more test case. So runtimes will obviously change a bit because of the hash function, but what is a good hash function on pairs, though, to be honest? I don't think Zoring is great because you get a lot of collisions. I think multiplication is, addition is better. The original code we used had a Zor, we can try that. Still one test case gone. USACO does not penalize resubmission at all, so there's really no harm in using the judge to help us debug. And we know our solution is correct. We just need that one test case. I really want to try shifting it to be 21 with the memory usage, because this will increase the runtime to that. But change the hash function to pairs actually got us much worse runtime on test case 3 and 4. Zoring is a terrible hash function, it looks like. One more time. I think if we don't get this, we'll leave with the one test case and move on to the other problems. I'm pretty sure this is the intended solution. Like, I feel like me in the middle is kind of obvious here, but how you avoid getting the time limits that tight, I'm not entirely sure. The hope is that you just get luckier on similar runtimes, but no. 4 seconds. I don't know if there's anywhere we can shave off a little bit of runtime. Yeah, test case 8. I think what's probably happening in test case 8 is that there's probably just more unique sums just by the nature of the test case. And so we're just getting unlucky and you get a lot more collisions. And just double check before we move on. What does 21 give us? Remember. I believe this memory limit exceeded, but double check. So of the other two problems, I think I want to think about number one. Number three seems like it's probably tedious implementation-ish kind of stuff. And it's not really the kind of problem I want to try to work. So now you get number number 8. Okay. Well, the best we got was one test case left. Is there anywhere we can decrease our memory usage? We're not really using that much. Oh, wait a second. Why am I doing up to 20? This should be half plus 1. Let's see here. That would drop memory usage in half. That might allow us to get 20. Trying, I think I got the index incorrect. Hopefully I don't get like index out of bounds. I know I said I was gonna move on, but small thoughts, try them. Obviously, don't want to spend too much time on what is one test case during an actual contest. You know, we still have 3.5 hours. We're not too worried, but it's worth thinking about whether it's worth our time to. Yeah, the memory limit dropped in half. If you notice, that was originally like 417. Now it's 257, and it's still TLEs. And it's well. Actually 20, because we should drop the runtime by that factor too. Okay. Otherwise, we'll start thinking about this one. I don't exactly know how to do it. We'll wait for that to change, but okay, so we have what's the problem? It's still gonna TLE. That's fine. Okay, so we have the sample, which I'll write out. What is the name of this problem? Redistributing gifts. Okay, so I'll write out the sample and then we'll start discussing my thoughts on this one. Okay, so what we have here, we want to know if we can like obviously reassign the gifts, like because you want to permute gifts, and a permutation can be written as a product of cycles, and they can be disjoint. So if we have like a permutation, you know, you can write it as like, you know, any permutation. Let's say you get like 2, 3, 4, 1. That's one cycle where 4 goes to 3, 3 goes to 2, 2 goes to 1, and 1 goes to 4. But the cycles are always distinct. So if you imagine, you could have distinct cycles. You could have 2, 1, 4, 3, where it's 2 cycles. Any permutation can be written like that. I guess if we want to reassign a gift, you know, if cow I wants gift J, we want to check if cow I can have gift J. We want to know, is there a cycle I goes to J, goes to all the way back to I. So I think it might be useful to represent the graph probably because we're going to start thinking about cycles and maybe like components or something. So in this case, if we look at the sample, our graph, we're going to have 4 cows. One can only have 1, but let's say we want to know, because 1 can obviously have 1. We don't draw the single loops, but 1 has no edges that come out of it because 1 has to have 1. There's nothing better. 2 can have 3, and it can have 1. 3 can have 2, and it can have 1. 4 can have 2, 3, and 1. We just get this by looking at, we have 4, and it has 3 higher priority ones, higher priority ones, and then 1 has just 1. So we want to know, is there a cycle including this edge? This makes me think of strongly connected components. So we have, if we want to know, can 4 have 2? We want to know, is 4 in a cycle with 2? But not necessarily in a cycle. Well, yeah, necessarily in a cycle, because you could just keep rotating the cycle until you get, it doesn't even have to be the, so when I said like here, I doesn't have to be next to J in the cycle, there could actually be like exchanges take place in between. So we want to know if there exists a cycle containing I and J in this directed graph. And if there is a cycle containing I and J, then I and J, this implies I and J, not capital J, are in the same strongly connected component, which I can mention what that is in a second. And if they're in the same strongly connected, this is clearly a cycle. So a strongly connected component, if you have some graph, you can split it up into components such that there is a path between any pair of vertices within the component, within each strong component, and then you end up with like a tree of strong components, or sorry, a DAG of strong components. And so if they're in the same component, then we know there's a path between them in both directions, which means there's a cycle. Of course, the cycle can include more of the same vertices, but you could obviously reduce the cycle to be a single cycle. Because yeah, it's kind of some argument we did. So yeah, I think we just need to check, if we want to know if 2 are possible, you have to check if they're in the same strong component. Strong components can be done in linear time on the graph using Tarjan's algorithm. I guess it's quadratic because the number of edges is quadratic. So we can compute SCC in O of V plus E time. This is called Tarjan's algorithm. Or like sometimes you'll see it's kind of related to like things that are like DFS low link. You can always find resources on these if you want to. But it might be hard to solve this without having already known how to find strong components. But strong components are a very useful topic. So we will get started on that. Okay. Just a second, let me make sure. Okay, so we can get started on this one. I guess we'll just call it. Again, try to template. Okay, so we want to do DFS. Mostly from memory. Okay, so let's see. Okay, so comp should contain. Okay, so we need to make our graph. Yeah. Let's see, the number of nodes we're dealing with is up to 500. Let's take. I guess I'll take in the preference. Equals. So if we're at struct 1, so there's 0 index, for ij equals I, then c equals true. If it's not seen, we can add this edge to our graph. So basically look at the ones before we find the one of the same priority, we add the edge from I to graph ij. Okay, so I think we've constructed the graph. We just DFS num. And I guess we're going to just okay, so now we need to find the SCs. This is just used to store like the stack of ones are still wait. So visit just stores like the current stack. The way we actually check whether we process a node is by checking whether this is -1. I think we have not reached it. DFS low is like this low link value where we take the yes. DFS. One and two are, because that's 2 and 3. So if we look at our original graph, 2 and 3 are indeed in the same SCC. These two, and then 1 is stuck and 4 is stuck. So it's become 3 SCCs. Okay. And we want to store our answers. So we'll do yes. Yes, actually. I can't min those. I need to like indices. We're going to loop over all pairs in this component, and if not equal to BV, advance V pref of V of. Now we can print our answer. No, I keep on full screen. So we're not line. And what will we get? That is not correct. Looks like they were never modified. We do have to add +1. And yes. 1324. 1324. No. I think that's kind of the idea. I don't know. There's a good chance of a bug, but there's really no reason not to submit. Yes. Let's see what happens. Paper to judge. All right, so if you don't know SSC from memory, like this is a kind of hard problem to solve. Well, that's not good. Wrong answer. All of them. Well, where did we go wrong? Hmm. I don't necessarily know the bug. The smart thing to do would be to generate a test case, but sometimes I find that it's worth just at least thinking about it for a little while. Hmm. Data flow should never be negative. I don't think it can be. I'm just thinking, it's not obvious to me where the bug is. Oh shoot, that's not this. I think let me do. I want to clear the entire list. One last. Have the components. We should get. So that's just not printing any components. Not good. That's some debugging prints. And just see what. I think we messed up our SCC implementation. Forgot the way. Yeah, okay. Past the samples. Let's try it. There's nowhere. So we're about an hour in. Not too bad. Especially if we get this problem. Let's wait for it to grade. It's taking a while to grade. I really don't know what to do for this one test case on the other one. to come up with something we can try, but okay, 13 agreed now. We implement SCC correctly. It's not good. Hmm. What's correct? Those are correct. Because you would be the root, and then we look at the stack after. I don't know the bug here. We can want to pair with anyone within here. What? I don't know. What the appropriate solution here is? We're doing something wrong. I feel like it might be necessary. I haven't written in a while. Maybe it's worth thinking about it on paper. If I can't figure it out. I don't know. Hmm. We do good. It doesn't matter which way we make the edges either, I don't think. So it doesn't matter if we make everything one index. Sorry. I think this is the idea for the solution. I don't think we're getting it wrong because we're trying a wild solution. I just think we have 5. Might be worth coding in SCC tests. What we'll do is we'll actually take in a graph and test our SCC code. We can print all the SCC's output and see whether it works. So we're actually not going to be running the problem. Otherwise, I really want to let me think of a graph for us to write. And try just a line graph first, like this. Here, there's no Sterling components. We could add edge 3, 0, 1, 2, 2, 1 is indeed make it a triangle. Where's the command? 0, 1, 1, 2, 0. Let's do like triangle. I feel like a 9. 1, 2, 3, 4, 5, 6, 7, 8, 9 edges. 0, 1, 1, 2, 0, 3, 4, 4, 5, 5, 3. That's not 9. I guess that's not a bad test case to try. 3, 6, 7, 7, 8, 6. Should be 3 little components. Try combining these 9, 11, 0, 1, 2, 3, 6, 7, 6, 8, 8, 6. Let's do 0 to 5 and 1 to 8 should give us still 3 strong components. That's not good. Oh yes, that's good. I mean, that's what it should be doing, but I'm really hoping it would fail. The fact that it won't fail. I mean, it's a good sign that that works, but it's not exactly what I. For. What else can we try? What can we try? one more graph test and then move. That can't be correct, can it? That seems a little odd. I don't know. Six. File. Oh, that's weird. Did I enter it wrong? 1, 2, 2, 0, 4, 4, 5, 3, 8, 0. Okay, yeah, that's the wrong edge. So I guess. 8210 are indeed 5 for 3 are indeed 7 actually gets isolated, I think. 7 points to 8, but 8 can't get to 7. So 6. I guess that's correct. Hoping that was a bug. Did I get? Is it pref? Oh. Let me try. Oh. Okay, so we're going to test this. I think I found the bug is just we were indexing it to the wrong array. That's entirely plausible. Kind of a sad bug, but it happened. It seemed weird. I was just trying to eliminate whether it's the SCC code or whether it's the actual problem code. It seems like it may have been the actual problem code. That would explain why I failed every test case, because it only got lucky on the sample if you're putting out the wrong outputs. Then yeah, there we go. That's nice. My problem is done. You can close it and not think about it anymore. This one seems really tedious to do. Don't think we're gonna get this test case super easily. I still kind of want to think about it. We're studying robots. I think we have enough time for all the problems at least. We shouldn't run out of time. Use a different hat. I still try different values. How do we randomize the hash function? Changing this value can complete the chance of say prime. Fair enough, 1 in 7 prime. It's not obviously not prime. So maybe that's worth trying. I mean, I really don't have a better idea there. Since k should never start at 0, that might give you have basis. I guess that's one step. That's not a current issue. What else can we change? You know, it's not obvious. What else we can change? I really think it would run in time if we made that 21, but it would run out of memory instead, which is the frustrating part. I don't think we can lower our memory usage very easily. I don't see anything obvious we can change besides just changing that hash value and see if you get lucky. There's a chance you'll get lucky. I removed one lookup, but it seems we definitely have a lot of submissions to this problem compared to the number on this problem. Otherwise, we do have to work on the third one, even though that one seems like it's going to be a bit tedious. I'm not too excited to try it. I think for this third one, we can basically simulate like where we are on the left side. So there's a couple observations I'm thinking is one, you always want to file when you can. Like if the folder's open, you want to file, and you only scroll on the folders when you're done with the folder, because otherwise we can never come back to the folders. You have to be done. If you're done, you might as well scroll. Oh, that was it. I just got lucky with the hash value, and maybe removing one lookup. Okay, I'll take that. Yes. Okay, so our two problems done. Oh, sorry, the screen share paused. That's not good. I guess you guys couldn't see that. Very sorry about that. The two things I changed, one was this lookup. Instead of creating the vector and then assigning it, which causes us to copy the vector, I made one lookup here, which eliminates one step every 2 to the half operations. And I also just changed the hash function to 1. So we probably got lucky with the hash function, or we were very, very close to the time limit. I don't know how long we passed. In the end, 3.2 seconds, very close to the limit. But we definitely maybe just got lucky with the collisions. So I'll take that. I don't think that's too big of a deal. Yeah, that's a bit frustrating of a problem. I also changed this to be max of use count 1. So a couple minor changes and somehow it passed. It's definitely a frustrating problem. But we'll move on from it because we solved it. We have this remaining problem. So let's think about this real quick. So there's a couple observations I would make. One of them is we only scroll folders when current top folder has no file left. And this is optional because you'd want to scroll if you can, because you don't need anything above it. You might as well scroll. And you can't scroll if this isn't true because you can never come back. So that's one observation. So it seems very easy to maintain the state of the folder scrolling. You just kind of scroll when you can. But to maintain the state, we also want to maintain like email lists. And I think we want to file whenever we can, i.e. folder is open. And I think you want to, if you're stuck, scroll anyway. Because if you get stuck and you can't file anything, then you have to scroll, right? There's only one choice. You can't scroll upwards, you can only scroll downwards and you're stuck. So you're never gonna finish if you don't scroll. So you have to scroll anyway. So I think what those will look like is something where we want to like start always scrolling down when possible. And once we reach bottom, we want to scroll upwards. And although we don't scroll upwards, like you don't actually like run the scroller upwards, we'll just like bring back in the emails from above if they can be filed and they help us. I think that's enough because we need to maintain, we can store our folders as just the start of range, but we can store the emails as a linked list. I think we need, so we need to be able to pop off both ends because we have to add an email to our current list of like the K that are visible. And we also want to remove an email from the end. And we also might want to be able to reference emails in between. And maybe you could use iterators. I don't know. It might be a bit tricky. I think that's an important question to answer. So if we scroll our folders, you might need to suddenly delete emails or like file emails that are already in your linked list. And maybe you could store like a map of each folder to the emails you currently have on the list. Or I think we can do this lazily. Lazily file only if you pop on or off. You can go through the list and move them in the linked list. You could delete them in between, but you have to have the iterator. I don't know how C++ iterators handle concurrent modification. It's a bit tedious and may not even work. And because of that, I don't really want to try that. I gotta make sure we have another solution. So I don't think that will work very well unless it was like actually 100% necessary. To solve this, lazily file only when we pop on or off. We just have to keep track of like how many folders in between we still need to file because we need to know like, what should the size of our list be. Because if there's some inside our list that are theoretically like filed, but they're just still in the list, we need to know how many there are. So there's a few. Let's get started on this one. There's a set of test cases. And then we take the emails. This M is the number of folders. Yes, but they come in NMK. NMK. make it all the input. We're going to want to do our forward scroll. We need to figure out what our state is. We need to know when to stop. Okay, we need to know what our, we're going to need. We'll need to pop it and move from. I don't know how deck is in Bloom's again. It may not actually be a linked list, but that's fine. This is the ones emails. Visible. Email. Initialize these next. It's not next folder. We'll keep track of it. So if next email is less than 10, so while there's another email to file, we would like to take that email and we'll just put it push back. The next email. I guess if we can file it, can file or file. File it, we want to file it. So if email greater than equal to current folder and email less than current folder, okay, then we can file it, right? So it's possible. If we need to keep track of how many we still need to file. Folder remaining. There's 10 to the 4 folders. So that. So if this folder is now 0, we can increment our current folder. I guess here we need to update like what still. We're gonna need something like should filed. So here we can keep track of those. So there is a folder here, should filed equals how many are visible. So I guess we're gonna need a variable for something like we need track of like how many each one are in the current range. Okay. Yeah, I guess it's reasonable. So we need to check if visible is too long. Visible that size is greater than a plus should file. And we need to pop back one. I guess we also need to know which should file if we pop it back, we don't want to keep it. We have to update our range. So if int email equals physical dot take off the front email if which should file email 0, then which I guess here we will also update remaining in the folder. That way this math still works out. We do need to make sure we actually scroll when possible. Minus. About that. We want to don't really want to add it to the list. If it's too long, because we're gonna we're gonna add it, but if and we just do it. Otherwise, we can't file. We'll put it on. Otherwise, seems reasonable that way we don't actually add to the list unless we need to. I guess we need to return. We should initialize a lot of these. This should be initialized to 0. This should be initialized to 0. So those are fine, but folder remaining needs to be. Need to initialize everything. A lot of things initialized. Okay. And I guess carried over from previous test case. We gotta remember we're using the same data for each test case. Yeah, I wonder if I guess we need to keep track of like number. This as well, which should file it. We just check. That'll be our output. And try running it to make sure everything compiles. And that's just a warning. So we'll take this test case. Test it, see if this works. See what happens. Yeah. Yes, yes, yes. And infinite loops. Okay. Obviously, should not pass the test cases, but it should terminate. And it shouldn't print yes if the answer is no, but it should print no even if the answer is yes. So there's something wrong on test case. 3, probably. Test case 3 is 1, 2, 4. It's got a K of 1. Just debugging output and see what we see. 0, 1, 2, 3, 4. Look at our current folder now. I'm mainly looking at test case 3 just because this one seems to be incorrect. Yeah, it should not be moving up, and I don't know why it is. It shouldn't be filing that email anyway. It's probably not the only bug. So it's good to test this early and make sure we can. Yeah. Okay, where is the tool? So see that the list shrunk and see if that happens. No, it doesn't even run. Oh, because we're not actually know which folder it has to go to. It's probably going to fix task is 3. That actually pass. Does that pass all the samples? I mean, I know it's not correct, but I would be a bit shocked if it passes all the sample. All right. Yeah, interesting. This is clearly not done because we don't scroll up. So here, what we're going to do, we need to keep track of some sort of like email. If will be equal to just the last email. It doesn't really matter which email we pick. I guess we do have to keep track of which ones are filed already. So that's gonna be another data structure we need to add. Otherwise, we can just do next back. Oh, we need to know where the emails are located. There's a couple issues here. Deck visible indices. And we need to back about already filed. Which emails we already filed. I guess we won't know. I guess we'll keep it with just when we update. Well, depends. We can't update that for the ones that are in the range but are still not popped off. We can update it for the ones that are. So we're gonna need to do. Can't update it there, so we'll have to do it here. Here we need to update index. That'll be useful because we're going to need to know which ones to skip over when we go backwards. So this will start. Otherwise, we'll do start right before our list actually currently is on. What else do we have to do here? Well, next back here and it's one to our list. So the email, we want to add an email. So if not filed, email. And that should be an else if we didn't file it. Already filed. Maybe that's the chance that this works is probably very low, but I think that is like the idea, and it completely fails. Interesting enough, it worked before and now it got worse. Print out. Should have gotten worse. It should have only fixed cases. Remaining should never be negative. So we always stay remaining. I wonder how many times. Should never be negative. Really weird. Let's start because it doesn't mean to start out. So we're trying to figure out where remaining is getting decremented too many times. print out this and see what that tells us. That just shouldn't happen. So now it's getting back on an extra one here, but that shouldn't be possible. I'm guessing. We do update in range the appropriate places, except for here. It's not. Yes. That's bug. No, 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 no. Yes. It's so negative. Interestingly enough. That's happening from. We really didn't even need to check up visible. I could have had visible indices. My mistake. These should be identical. Let's go back. Just a second. Let's in between print out. Currently in our range between the two steps of the algorithm. See what we get. We should expect it to be. Well, I guess we have one in range. We didn't file it already. Or we did file it. So what is next spec email become? Visible. It's getting pretty tricky debug. I mean, this is kind of expected with something that's very implementation heavy. Visible is empty. Well, that's odd. It's too big. We have to pop up one. Even if it's equal to the right size, we have to pop up one, pop it off, and then we file. You want in range to be set correctly before we file, because the scroll has to happen before you file the next email. I think this is the problem we can get. It's just going to take some time. Visible should not be empty, though. Here, of course, it's empty, but on what is the second test case? 1, 2, 3, 5, 4. But you do 1, 2, 3. Why does it file? Well, I guess because it scrolls anyway and it gives up the 5 and then it files the 4 and now it's stuck and has to give it back. Oh, this should not be inside the loop. It should just pop off, and only if it should be filed, then we file it. That's one bug. And let's see what that does. No, no, yes, no, no, yes. Oh, we commented out. Back. This looks more what I expect. No, yes. No, 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 yes. Well, at our next back part. See if it even processes it. So it does try to process that's the correct email index you're processing. That. 1, 2, 3, 8. Yes. So if not already filed next back email, because this is already, we needed this. I'll skip over values. No, yes. No, yes. Scroll back. Somebody doesn't process that one. What they file? Oh, that's in there. Expect the current folder to be 4 before we start on task case 2. Go back. This one's already processed, and so we're gonna look at. It's not the same. Maybe we're marking it already filed when it shouldn't be. It shouldn't be filed. Already filed next email. It's true. That's not good. That should not happen. So somehow the issue is we're setting already filed when we shouldn't. And that would be because we did not. So one thing. You gotta make sure you initialize everything. No, yes, yes. No, yes, yes. It is good. Let's try submitting it, I guess. There's probably a very good chance there's a bug in here. So that's expected, but we can at least see if it's anywhere close or if it's gonna fail. I wouldn't do this in some kind of where you'd be penalized for not testing it, but USACO, there's really no harm testing using the judge. So let's submit emails. It's not bad. Oh, that's pretty good. Okay. That's solid. What the issue is. So we can't test on the sample because we don't ever pass it the sample. I think this should be a while loop. That's not good. We want to shift the folders as many times as we can. Oh. Make sure we have the check for the indices being in range. Oh, let's try it again. I mean, that's a bug, so. Still one test case, or three. Well, that's a test case we used to fail. That should be a value. Well, I guess if the first folder is 0, that doesn't work, right? So the issue is we're scrolling our folders. We only scrolled once before. Now we're scrolling in a loop. But if the original folder was 0, this. Probably still gonna pass the sample. Let me try something in a second. That's not the bug we're gonna probably spend. Same test case. Yeah. Well, we found one bug. Do we initialize everything? Clean that up a little bit, maybe. Another thing we do is add asserts. Let's find bugs we can submit and see if we can run hires. Okay. Make sure it still works. I think everything's initialized. There's I'm only finding 3 test cases. So if you get stuck, you have to give up, which is fine. check. So we can start adding asserts, like I know what we should assert. Other things you can check is there are certain variables that should always be modified together, like in range, visible, and visible indices always go together because they're maintaining the same data structure, right? So if we ever modify one but don't modify the other, that's a bad sign. Seems we do always modify them together. Remaining and folder remaining always get modified together. You can see there. And I guess already filed. Well, it should get modified when it actually doesn't get added to the list. So, and already filed, and then should file and which should file should always be modified together. Or you find email, you should scroll the folders, which we do. And we scroll the folders at the start because we did that here. So this is an important line. We do want to update this here because otherwise it may not be able to scroll later. Wonder what we can do here. Okay. So I think either finding test cases locally or doing more asserts probably the move. Hmm. No, these are one. Hmm. I'm not sure here. Mm, okay. Like right now, I'm not really sure what part of the code to be looking at because it's not. That's it. Do we make sure it always account for should file? Like here, we have to actually include this because you can scroll as long as you have, because there's like emails that should have already been filed. Same with here. So those are important. So we pop this off. We do want to update should filed, which should file, already filed, and only 3 test cases too. Because even if I test locally, if we're passing it a lot, it's gonna be really hard to figure out what is causing it to fail. Just 3 test cases, unless you have an idea of like what's a good edge case. And here, like it's hard to know what would be a good edge case. So the options are like you can add asserts, but I think a lot of the asserts are gonna be trivial. Like I don't know what to assert to debug this, unless we just asserts will help us find like we made assumptions that like certain things are in range. But you know what? I think we have another, because if this statement runs right here, should file, so does what size. What happens is this for loop should still be true. I think it's just supposed to be a while loop. This is the kind of problem where like it feels pretty hard to find the bug just by like testing it locally, unless you have a good idea of what test case to the test. And so here, it feels like we're kind of forced to just analyze our code more carefully rather than find the bug another way. It completely failed the sample if I do that, which is not good. Something else. Not. Okay, so I think I found the bug, but I somehow introduced the bug. I introduced the bug there, and I didn't test it, which is a silly thing to do. Test it because I modified the code there to make it more concise, but I actually introduced the bug. So undid what we did, and there we go. Let's see what we get. It's at least one bug. Hopefully it's the last bug. If it's not the last bug, I'm not sure what we're gonna do. Okay, passed one more. That's all. Okay, so that is all three problems. That's not too bad. I think, it is a good idea we start with rote instructions. I think emifying is the kind of problem where like it's very plausible you'll be unable to finish in time. And it's very hard to debug. This one, you kind of have to know an algorithm like SCC. I'm curious if there's a solution that doesn't involve SCC. Maybe it's possible, but I think like DFS low link and like related like properties and like algorithms you get just Tartan's algorithm are generally silver topics. So it's plausible. Meet in the middle. You should remember this technique. If you see a problem where you can enumerate all subsets and you want to do it on about 40 instead of about 20, then that's kind of a hint to try that. Otherwise, that's the contest. Reasonably tricky problems. This one ended up being a lot of code. Yeah, that will be the end of the contest. That is all we have. Stop sharing. So thank you so much for watching. Hopefully this benefits you in some way. These are contests are obviously generally pretty tricky, and silver can get pretty hard. But I hope you guys did well. I hope this benefited you. So thank you.